All right, guys, we're on problem number 7. So first thing I want to do is factor out the numerator. I notice that 2x cubed and 2x has a GCF of a 2x. So I pull that out. So on the side, I'll do 2x cubed divided by 2x. 2 divided by 2 is 1. And x cubed divided by x to the power 1 is x squared. So that goes there. I also know that 2x divided by 2x is just 1. So we have that. So you always want to see if you can factor out the GCF first. There we go. In our denominator, right, we have the good old difference of cubes. A squared minus b squared is a plus b times a minus b. And so 1 is the perfect square. So this is just like saying x plus 1, x minus 1. And we are done. Nothing cancels out, so we have no holes. And we move on. For the x-intercept, we set the numerator equal to 0. So our numerator is 2x, x squared plus 1, right? We can only do this if we have a single fraction, like so. So we set this equal to 0. We take each factor, set it equal to 0, and then solve for x. On the left, we divide both sides by 2. So x is 0. On the right, we need to subtract 1 and then take the square root. Don't forget the plus or minus, but this is not possible. You cannot take the square root of a negative number. So therefore, there's only one x-intercept at 0, 0, which means that the y-intercept is 0, 0. We don't really need to waste our time, but if you really wanted to waste your time, you could just do g of 0 is 0 plus 0 over 0 minus 1. 0 plus 0 is 0, and 0 minus 1 is negative 1. 0 divided by negative 1 is 0. All right, moving forward, we need to find the vertical asymptotes. To find the vertical asymptote, you look at the factor version, which is this guy. Take our denominator, which is x plus 1 times x minus 1, set it equal to 0, and solve for x. I'm going to separate them. X plus 1 is 0. Therefore, x is negative 1. X minus 1 is 0. So I add 1 to both sides. Therefore, there are two vertical asymptotes at negative 1. Whoop, and positive 1. Bam. To find the slant asymptote, we notice that the degree of our numerator is 3. Sorry for my Duolingo. The degree of our denominator is 2. All right. So, after we do that, we do the long division. So, let's see. We have x squared minus 1 here. And we have 2x cubed plus 2x over here. This is going to be plus 0. So we need to see how many times does x squared go inside 2x cubed. So we do 2x cubed divided by x squared. That's just 2x. So 2x goes on top. All right. So now we do 2x times x squared minus 1. That gives us 2x cubed minus 2x. So we subtract that. 2x cubed minus 2x. So notice that these two cancel out. And let's see. Oh, you know what I did? I'm missing the 0x squared, but that's fine because this actually works out. 2x minus negative 2x is like saying positive 4x. So that's our remainder. And we're done because 4x squared can't go inside, x squared can't go inside 4x. So this is my, it looks kind of weird, but this is my slant asymptote. Slant asymptote is y is equal to 2x. And we are done. So the slant asymptote is 2x, which means it has a y-intercept of 0. And it goes up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Or it goes down 2 to the left by 1, 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 down to the left by 1. So there we go. It looks something like that. So it crosses its own slant, which is kind of cool. All right, so we have that. And now we just need to make a table of values and plug in values for our sign chart. So for our sign chart, we want to plug in values to the left and to the right of the vertical asymptotes, which are at -1 and at +1, right? There's also an x-intercept of 0, so we need to include that. So let's say I want to plug in like 2, right? If I plug in 2, we should get a positive number. So like you should like plug in 2, right? 2 goes in, you should get like 20 over 3, which is a positive, right? You should try to plug in numbers to like between 0 and 1, like, I don't know, 1/2, right? aka 0.5. If you plug in 1/2, you are going to get a negative number. So you can try that out. Try plugging in like a number like -1/2. You should get a positive number. And if you plug in a number to the left of -1, right? If you plug a number to the left of -1, you should get a negative. So notice how they always alternate between negative, positive, negative, positive. And remember, the reason why I got this is because this is a vertical asymptote. This is a vertical asymptote. And 0 is an x-intercept, right? You always want to put the critical values as your x-intercepts and your vertical asymptotes. So by knowing so, we know that, right, left of -1, it should look like that because it's negative. Between -1 and 0, it's positive, so it's like this piece. And then between 0 and 1, it's negative, so it's like this piece. And then I think if we plug in like 3, you get like 7.5. 3 is like 7.5-ish. 2 is like saying 20 over 3. Right? 2 is like saying 20 over 3, which is like saying something like that. If you plug in like -2, you get like -6.7. So you just use the calculator, taking like -3, you get like -1.5, right? So I would suggest that you plug it into this form, the factored form. You can also plug it here. You can crank it out, work like that. I just simply make a sign chart, so I know my end behaviors. So like if I ask you like, what's the limit as x goes to -1, right, from the left? It just goes down to -infinity. The limit as x goes to 1 from the right of f of x, that's positive infinity. Because I look at this, left, negative, right, positive, right? And I can also do that for the limit from the right, right? So limit from the right of 1, it's going to positive infinity. The limit as x goes to 1 from the left is -infinity, right? So here's 1 from the left, it's going to -infinity. From the right, it's going up to positive infinity. And we are done. Oh, we also need to do the domain, which is pretty straightforward. It's all real numbers where x does not equal to plus or minus 1. And we're done.